So these two functions, exponential and logarithmic functions, we start by analyzing the graphs of these two functions, okay, in general. So for this session, we need to know how to find the domain, the range. We have to learn how to graph, finding intercepts, zeros, and asymptotes of the two functions, exponential and logarithmic functions. So let's start with these two exponential functions. Okay, so we need to graph the two, and we have to investigate. Okay, when we graph exponential functions, first we have to check what is the base function. This y equals 2 raised to x minus 3 plus 4 is based on the graph of 2 to the x, which we learned how to graph earlier. Y equals 2 to the x should have, what is the y-intercept? If y is equal to 2 to the x, what is the y-intercept? If we forgot the property, how do you find the y-intercept? Make x equal to 0. So y is equal to 2 to the 0. 2 to the 0 is 1. So it will cross the y equals 1. Asymptote is at 0 or the x-axis. Will it be going up from left to right or going down from left to right? Going up, because the base is bigger than 1. So we expect the graph to behave like this. But that is 2 raised to x. That is not the one we are graphing. What we want to graph is y equals 2 raised to x minus 3 plus 4. Then we learn, or we apply what we learned about translation of axes. What will be the effect of minus 3 on the x? To the right by how many units? 3. Okay, so select this reference point and move it 3 units to the right. Initially, it is located at 0. So it has to move at 1, and then 2, and then 3. So that point earlier is now here. But that's not the only movement that we have to do. We have the plus 4. After moving the point 3 units to the right, that point will move 4 units up. So if this is 1, so this is 2, that's the first jump, 3, second jump, 4, third jump, and then 5, that is the fourth jump. And don't forget, the point that we are using is this. Okay, so that point has to move 4 units up. 1, 2, 3, and then 4. So it will now be located at y equals 5. Okay, aligned with y equals 5. What will happen to the asymptote? It should go with that point. The asymptote is 1 unit away from the y-intercept. So if that y-intercept is now located at 5, then the asymptote must be at y equals 4. Okay, it is called translation of axis because the x-axis is like moved to that line from 0 to 4, y equals 4 units. Okay, and if we have an imaginary line here, this is the line, this is the y-axis, move 3 units to the right. Therefore, knowing the orientation of the graph should follow this path. We cannot graph the exact, we cannot draw the exact graph, but we can estimate its orientation. It's going up. The new point will be, take note, this point. If we name this point, this is actually at x equals 3, and this is at 5. If we want to name the point, it's 3, x equals 3, y equals 5. Okay, from 0, 1, naging 3, 5 siya. Okay, are there any questions? So knowing the base graph, even if I give you a complex equation like, or function like 2 to the x minus 3 plus 4, just apply the translation of axis. 3 units to the right, 4 units up. The graph follows 2 to the x, it should be going up. Okay, clear? Let's check the next. How do we graph y equals log base 2, x minus 1 plus 3? Translation will be, describe natin, 1 unit, where? 1 unit to the right, and what else? 3 units up. But first, we need to identify where the graph is based. Right? The graph is based on this, log base 2x. So let's review, how do we graph log base 2x? Log base 2x. The base is bigger than 1. Increasing graph or decreasing graph? Increasing. And this is already in the log. The graph of the logs, dito lang siya. And they will intersect at x equals 1. So we have increasing. At the same time, the asymptote is the counterpart of the 2 to the x. In the 2 to the x or b to the x, the asymptote is the x-axis. For log, the asymptote is the y-axis. So it has to be increasing, and the graph should behave in this way. See, the asymptote is being used in the lower part. Okay, so once we know the graph of log base 2x, we can now graph y is equal to log base 2 of x minus 1 plus 3 by analyzing the translation of axis. We said 1 unit to the right and 3 units up. Focus on the most important point, the 1. 1 unit to the right means the 1 becomes 2. Initially, the point is here, but you have plus 3. That point will go up by 1, 2, and then 3. So it will be at 1, 2, it will be at 3. So that is or the location of the point. Where is the vertical asymptote? It moves with the point. Minus 1, 1 unit to the right. The asymptote will also move 1 unit to the right. So the green dashed line will now be from 0 it is now at x equals 1. Okay? The x-axis, sana yung x-axis natin? It should be, ilan yung move niya? Plus 3 ba? 1, plus 1, minus 1, and then plus 3. Okay, so we have to recreate the graph following the points and the asymptote. So, nandito na siya. Yan. Okay? Yung x natin, na-move na siya dun sa 3. Kuha?